All right, so have you ever wondered how a tiny app, maybe something you'd build on a weekend, turns into a massive platform that serves millions of people? Well, it's definitely not magic. It's all about something called architecture. And you can think of it just like a blueprint for a house. It's what decides if your app is going to stand strong or just crumble under pressure. So let's break that blueprint down. Okay, so picture this. You've built your first app. It actually works. It's live, and hey, your first 100 users absolutely love it. Awesome, right? But now comes the hard part, the real challenge. How do you take that success and scale it up to, say, 100,000 users without the whole thing just crashing and burning? Well, the answer, as we're about to find out, is all in that architecture.
So, what is web app architecture, really? Well, it's that foundational plan. It's the blueprint that lays out exactly where every major piece of your app goes. You know, the front end, the back end, the database. But even more importantly, it defines how they're all going to talk to each other. If you get this part right from the start, you're building on some seriously solid ground.
All right, to really get a handle on this whole blueprint idea, we're going to look at it in two different levels. First, we're going to start at the very top, the big picture, the network layout. This is all about where your different components, like your servers and databases, physically live and how they actually communicate with each other over the internet.
And really, we have to kick things off right here with what's called the client-server model. Why? Because it's pretty much the fundamental building block of the modern web. I mean, think about it. From the social media you're scrolling through to your online banking app, almost everything you use is built on this exact principle.
So this model actually evolves through what we call tiers. You've got your one-tier setup where absolutely everything, the client, the server, the database, it's all crammed onto a single machine. It's simple, sure, but it gets crowded fast. Then you have a two-tier setup, which is a step up. Here, you pull the database out onto its own machine. But really, the gold standard, the industry standard, is the three-tier setup. This is where the client, the server, and the database each get their own dedicated machine. And that separation, that is absolutely key for managing complexity and, you guessed it, for scaling up.
Okay, let's make this super real for a second. Think about YouTube. The moment you click on a video, your browser, that's the client, sends out a request to YouTube servers. Those servers then spring into action. They do all the heavy lifting. They find the video file, they grab all the comments, they figure out the recommendations, and then they package all of that data up and send it right back to your browser. Boom. That's the client-server cycle in action, happening millions of times a second.
But you know, client-server isn't the only game in town. There's another major player, peer-to-peer, or P2P for short. The core difference is actually pretty simple. Instead of having everything rely on one central server, a P2P network is made up of a bunch of equals, we call them nodes, that all talk directly to each other. There's no single boss, no single point of control.
So, why on earth would you choose P2P? Well, one massive reason is to avoid having a single point of failure. I mean, do you remember that time when Facebook and all its apps just vanished from the internet for hours? That was a central server issue. P2P is designed to avoid exactly that. It's also the absolute backbone of Web3 and blockchain tech. And you even see it used by companies like Blizzard to let gamers download huge game files from each other, which is way more efficient.
Okay, so that pretty much covers the network layout, that big picture, physical arrangement of our system. But listen, that's really only half the story. Now we need to zoom in a bit and look at the other super crucial piece of the blueprint, how the code itself is actually organized.
All right, let's dive into level 2, the code structure. This is where we get into the nitty-gritty of how you actually design, organize, and manage the code base that makes your application, well, come to life.
So, here we have the two main ways to think about this. On one side, you have the monolith. Think of it as one single, giant, tightly coupled unit of code. And on the other side, you have microservices, which is a collection of small, totally independent services. And really, it all boils down to trade-offs. A monolith is way simpler to get started with, no doubt. But if one little part fails, the entire app can crash. With microservices, if one service has an error, it's contained. It doesn't take everything else down with it.
You know, this quote right here probably feels very familiar. I'd be willing to bet that if you've ever built an app, you unknowingly started with a monolith. We all do. You just put all your code into one single code base because, hey, it's simple and it's fast. And that is totally fine. But the real key is knowing when you've outgrown that model. And the telltale sign is usually when your development teams start tripping over each other. And fixing one tiny bug means you have to do this massive, risky redeployment of the entire application.
So let's go back to our YouTube example. In a microservices world, you'd have the recommendation engine as one service, the search function, that's another service, the comment section, yep, a third service. Each one of these can be built, deployed, and even scaled completely independently by different teams. So think about it. If the comment service crashes, who cares? You can still watch videos and search for new ones. That's the real power of modularity.
But wait, we can actually take this idea of breaking things down even further. And that's where serverless architecture comes in, sometimes called function as a service. With this approach, you break your services down into even tinier pieces, just individual functions that run when something happens. All you have to do is write the code for one specific task, and a cloud provider, like AWS Lambda or Google Cloud Functions, handles all the messy server management for you. Pretty cool, right?
Phew, okay. We've just covered a ton of concepts. So let's try to tie it all together and see how it works in a real practical example. Let's imagine we're building an online store.
So let's say the shipping process for our online store is built using a serverless approach. It basically becomes a chain reaction. It all starts with an event, right? Let's say an order gets marked as ready to ship. Boom, that triggers the first function, maybe one that validates the customer's address. When that one's done, it triggers the next function to generate a shipping label. And when that's done, it triggers a final function to send out that confirmation email. See? It's just a cascade of small, independent tasks all working together to get a complex job done.
So what's the big takeaway here? It's that this is all about trade-offs. There's no magic bullet. This chart really sums it up perfectly. On one end, you have the monolith. Super simple to start, but really hard to scale. Then you've got microservices, kind of sitting in that middle ground. And all the way at the other end is serverless, which gives you absolutely insane scalability, but it definitely comes with more complexity.
And all of this brings us to the final and honestly the most important part of this whole discussion. How in the world do you choose the right plan for your project? Because at the end of the day, there is no single best architecture. It just doesn't exist. It's always a series of deliberate choices and trade-offs. The right blueprint for you isn't necessarily the most complex one or even the most scalable one. The right blueprint is the one that perfectly fits the specific needs, the timeline, and the goals of what you are trying to build.
So, next time you go to build a new project, or maybe you're thinking about how to scale one you're already working on, I want you to remember this: your app's entire future, its resilience, its speed, its ability to grow,